All right, so we're diving into patterns in math today.
Okay.
You've sent over a ton of stuff on this. It
Yeah.
looks fascinating.
Oh, it is. It is.
This deep dive is going to be, I think, pretty
I
amazing.
think so too.
We're going to be looking at different types of mathematical patterns, and we're
Right.
going to kind of unpack like why they're important.
Yeah.
I'm hoping we can unlock some secrets of the universe.
Absolutely. Patterns are kind of like that.
Yeah.
The elegance
Yeah.
and the order underlying some of the most complex phenomena.
Right.
It's like nature's blueprint.
Yeah.
They're kind of whispering secrets of how things work.
Oh, I like that.
Yeah.
Well, one thing we see every day is symmetry.
Right.
And it seems so simple, but I bet you there's more to it than meets the eye.
You're absolutely right.
Yeah.
There is a lot more to symmetry than just a pretty picture.
Yeah.
In its most basic form, it's really a balanced arrangement of parts, like a butterfly's wings
Right.
or the human body.
Yeah.
But this balance actually translates to stability and efficiency in nature.
So nature favors symmetry because it's stronger.
In a way, yes.
Okay.
I mean, it's more resistant to stress,
Okay.
and it just works better.
That makes sense. But how does this concept apply to math itself?
Symmetry in math gets into the concept of transformations that leave certain properties unchanged.
Oh, okay.
So, for example, imagine the equation x plus y equals y plus x.
Okay.
You can swap x and y, and the equation still holds true.
Right.
It's like a mathematical mirror image reflecting a deeper truth.
Okay, I'm starting to see how this seemingly simple concept has some pretty profound implications.
It does.
It's like a hidden code that governs the structure of things.
Yeah.
Now, our sources also mention other types of patterns like arithmetic and geometric sequences.
Yeah.
Those seem a bit more abstract.
They might seem abstract, but they're everywhere.
Really?
Oh, yeah.
I-
Arithmetic patterns are all about adding a constant difference.
Okay.
Think of climbing stairs. Each step is the same height.
Right.
It's a simple pattern, but it's the basis for calculating things like interest rates
Oh.
or predicting growth.
So it's like a steady, predictable increase.
Exactly.
Okay.
Now, geometric patterns are based on multiplication.
Okay.
You start with a number and multiply it by a constant ratio to get the next one.
Got it.
So think of a chain reaction where each step multiplies the previous one.
So something like 2, 6, 18, 54,
It's
where we're
all-
multiplying by 3 each time.
Got it.
Okay.
This type of pattern is essential for understanding things like population growth
Oh, wow.
or even the spread of a virus.
Hmm.
It's all about exponential change.
So these seemingly simple patterns have some pretty powerful real-world applications.
Absolutely.
Wow. Now, speaking of powerful patterns, I've got to ask about the Fibonacci sequence.
Right.
It seems almost mystical how it pops up in nature.
It is. It's kind of spooky how it's just everywhere.
Yeah.
But the Fibonacci sequence is where each number is the sum of the two before it. So 1, 2, 3, 5, 8, and so on.
Right.
And you're right.
Yeah.
It's uncanny how often it appears in nature,
Yeah.
like the arrangement of petals on a flower to the spiral of a nautilus shell.
It's everywhere.
Yeah.
Why is that? Is there like some evolutionary advantage to this particular arrangement?
Well, scientists and mathematicians believe the Fibonacci sequence
Okay.
and its close relationship to the golden ratio
Mm-hmm.
reflects an efficiency of space and resources.
Okay.
So think of the seeds in a sunflower head arranged in a Fibonacci spiral,
Okay.
maximizing their exposure to sunlight.
Wait, so the arrangement of seeds in a sunflower is actually optimizing sunlight exposure.
Yeah, it's pretty cool, huh?
That's incredible.
Oh,
It's
but
like nature IS, a mathematician.
I know, it really is.
Yeah.
And this connection to the golden ratio, a proportion often found in art and architecture,
Yeah.
adds another layer of intrigue.
Yeah.
It's believed to be inherently aesthetically pleasing to the human eye.
Huh. So the Fibonacci sequence isn't just a mathematical curiosity.
No.
It's a blueprint for efficiency
Yeah.
and beauty in nature
Yes.
and even in art.
Yeah, a lot to unpack there.
I know, that's a lot to unpack.
Yeah,
Are you ready to dive into something a bit more complex?
absolutely.
All right. Our sources also mention something called tessellations.
Oh, yeah.
That sounds a bit more intricate.
Tessellations are patterns formed by repeating shapes that fit together perfectly without any gaps or overlaps.
Okay.
The classic examples like a tiled floor
Oh, okay.
or a mosaic.
Yeah. Yeah.
Uh-huh.
Those intricate patterns can be mesmerizing.
They are.
But I have a feeling there's more to tessellations than just aesthetics.
You're absolutely right.
Yeah.
Tessellations have practical applications too.
Okay.
especially in fields like engineering and design.
Oh, okay.
So think about packing problems,
Okay.
like figuring out the most efficient way to arrange products in a box.
Right.
Tessellations help us optimize space and materials.
So those seemingly simple patterns can actually help us solve complex logistical problems.
Absolutely they can.
That's fascinating.
It is.
I never would have guessed that those pretty tile patterns could have such practical applications.
It's pretty amazing how something that seems purely aesthetic can hold the key to efficiency and problem solving.
Right.
And this is just one example of how patterns connect seemingly unrelated fields,
Yeah.
revealing a deeper level of order and structure in the world.
Okay, my brain is officially buzzing with all these different types of patterns
I bet.
and their real-world applications, but maybe we should take a step back
Yeah, good idea.
and address the big question.
What's that?
Why should we care about patterns?
Ooh, that's a crucial question.
It is?
It's easy to get caught up in the wow factor.
Right.
But understanding patterns is about more than just recognizing them. It's
Yeah.
about developing a way of thinking, a way of seeing connections,
Okay.
underlying structures that can help us in all sorts of unexpected ways.
So it's like training our brains to see the world through a mathematical lens.
Exactly. And that can be incredibly empowering.
Yeah.
It allows us to solve problems more effectively, make predictions,
Right.
and even spark new ideas.
Okay, I'm starting to see the bigger picture here.
Good.
It's not just about memorizing sequences or formulas.
No.
It's about developing a deeper understanding of how things work, how they connect,
Yes.
and how we can use that knowledge to our advantage.
Precisely.
Okay.
And once you start seeing the world through this lens, you'll find patterns everywhere you look.
Really?
Oh yeah, they're hidden in plain sight, waiting to be discovered.
Oh, all right. I'm officially ready to embrace my inner pattern detective.
Right.
But before we go on a full-fledged pattern hunt,
Yep.
let's unpack a few more examples from our sources just to get a sense of the incredible variety out there.
Sounds good.
We've talked about Fibonacci, but what about those other sequences like square numbers and triangle numbers?
Those are great examples of how even seemingly simple patterns can have surprising applications. Square numbers, for instance, are essential in physics and engineering.
Oh, okay.
They pop up in calculations involving areas, forces,
Wow.
and even the intensity of light.
So something as simple as multiplying a number by itself can have all sorts of practical implications.
It can. It's pretty cool.
I never would have guessed that.
Yeah, and triangle numbers,
Yeah.
which are formed by adding consecutive positive integers,
Hey.
are all about understanding combinations and possibilities.
Like choosing friends to go to a concert, that's a triangle number in action.
Exactly. But this concept goes way beyond concert buddies.
Oh, all right.
Triangle numbers are used in algorithms,
Wow.
statistics, data analysis,
Really?
even game theory.
Wow. Who knew those seemingly abstract number sequences could have such practical uses?
It's pretty wild.
Okay. I think we need to pause here for a moment
Okay.
and let all of this sink in.
Sounds good. It is a lot to take in, isn't it?
It is.
All these patterns and applications.
Yeah, it really is.
But that's the beauty of patterns, right?
You know, it's like this hidden language that governs everything.
Right.
From the tiniest seashell to the vast expanse of the universe.
It really is. It's like this hidden language.
Yeah.
And if we learn to speak it,
Yeah,
then it just opens up this whole new way of understanding the world.
it does. And, you know, patterns aren't just about recognizing them.
Right.
They're also about figuring out why they exist.
Okay.
What are the underlying principles driving these repeating structures?
So it's not just about what we see,
Exactly.
but about understanding the invisible forces at play.
Yeah, precisely.
Okay.
Take the Fibonacci sequence, for example.
Yeah.
Why does it appear so consistently in nature?
Right.
Well, scientists and mathematicians believe it has to do with efficiency.
Okay.
The Fibonacci spiral allows for the most compact arrangement of elements,
Okay.
whether it's seeds in a sunflower head or leaves on a stem.
Right.
This optimal packing ensures maximum exposure to sunlight or nutrients.
Wow. So it's not just a coincidence.
No, not at all. There's an evolutionary advantage to this particular pattern.
Exactly.
That's incredible.
It is. It really is.
Okay, my brain needs a minute to process all of this.
Okay. No problem.
It's like all those random facts I learned in school suddenly have meaning now.
I know, right?
Like those triangle numbers you mentioned earlier?
Yeah.
They always seemed kind of pointless.
Oh, they're not pointless.
But now I'm wondering where they pop up in the real world.
They're everywhere.
Really?
Oh, yeah. Triangle numbers,
Okay.
for example, are related to the concept of combinations.
Okay.
Imagine you have 3 friends,
Oh.
and you want to choose 2 of them to go to a concert with
Right.
you.
Right.
How many different combinations are possible?
Let me think.
Okay.
I could go with friend A and friend B,
Okay.
or friend A and friend C, or
Mhm.
friend B and friend C.
Yeah,
So 3 combinations.
exactly. And that's the third triangle number.
Mm.
If you had 4 friends and wanted to choose 2,
Yeah.
there would be 6 possible combinations.
Really?
That's the fourth triangle number.
Wow.
It's a pattern that helps us understand and calculate possibilities.
Mind blown again.
They're everywhere, these patterns.
Yeah.
They pop up in the strangest places.
I never would have guessed there was a connection between triangle numbers
Yeah.
and picking friends for a concert.
It's pretty wild, but that's the beauty of it, you know? Patterns connect seemingly unrelated concepts,
Right.
revealing a deeper level of order and structure in the world.
It's pretty amazing.
It is.
And the more you understand these connections, the more you start to see the world through a mathematical lens.
Absolutely. It's like having a secret decoder ring for the universe.
It is.
But before we continue this quest for hidden patterns,
Yeah.
let's move on to part 2.
Okay, sounds good. Okay, so we're back
Back again.
for the final part of our deep dive into patterns and mathematics.
Right.
We've uncovered so many fascinating connections already,
We have.
from the natural world to abstract concepts.
It's amazing, isn't it? How these underlying principles of patterns
Yeah.
just seem to weave through so many different areas of our world.
It really is. And as we were talking about all these different patterns,
Right.
I couldn't help but think about how they show up, not just in math and science,
Yeah.
but in art and music, too.
Absolutely. Music and art are fantastic examples of how patterns create beauty,
Right.
emotion,
Yeah.
and meaning.
Okay.
Think about a piece of music you love.
Okay.
It's all about patterns of sound,
Right.
melody, rhythm,
Yeah.
and harmony.
It's true.
You know those repeating melodies?
Right.
The driving beat of the drums?
Yeah.
The way different instruments blend together?
Yeah.
It's all carefully structured
Mhm.
using mathematical principles.
It's like those patterns create a kind of order
They do.
that our brains find inherently pleasing. No
Yeah.
wonder we get lost in the music.
Exactly.
Yeah.
And just like in math,
Okay.
some patterns in music just seem to resonate with us on a deep level
Okay.
across cultures and time periods.
Wow.
The major and minor scales, for example, have been used in music for centuries
Yay.
and evoke a wide range of emotions.
That's fascinating.
It is.
And it's not just music.
Yeah.
I've always been fascinated by visual art.
Okay.
That uses patterns like those intricate Islamic tile designs.
Yes.
Or optical illusions that play with repeating shapes and colors.
Yeah.
Yeah.
Art is another powerful example of how patterns can be used to evoke emotions,
Right.
tell stories,
Mm-hmm.
create a sense of movement,
Right.
and even challenge our perception.
It's true.
Those Islamic tile designs you mentioned,
Yeah.
they often use complex geometric patterns
Right.
that can create a sense of awe,
Oh, yeah.
wonder,
Yeah.
and even spiritual contemplation.
I can see that.
Yeah.
And then there's architecture,
Yes,
which blends math, art, and engineering so beautifully.
it does.
Buildings like the Taj Mahal or the Pantheon are full of symmetry
Yes.
and geometric patterns.
It's amazing.
It's like those patterns give them a sense of grandeur.
right. Harmony
Mm-hmm.
and timelessness.
You hit the nail on the head.
Yeah.
In architecture, patterns aren't just decorative.
Oh,
They're crucial to a building's structural integrity
right.
and functionality.
So they serve a real purpose.
They do.
Okay.
Think about the arches and vaults in Gothic cathedrals.
Okay.
Those patterns aren't just beautiful. They distribute weight and create strong, stable structures.
It's mind-blowing to think about how these underlying principles of patterns
I know.
connect so many different creative and intellectual pursuits.
It really speaks to the power of mathematics.
It does.
As a universal language.
Yeah.
Whether we're talking about the spiral of a galaxy,
Wow.
the rhythm of a heartbeat,
Wait.
or the harmony of a musical chord,
Yeah.
there's an underlying mathematical structure at play.
Yeah, it really is like a hidden code that unlocks the secrets of the universe.
It is.
Okay, this has been such a mind-expanding deep dive.
I'm glad you enjoyed it.
I feel like I'm seeing the world in a whole new way now. Noticing patterns everywhere I look.
I'm thrilled to hear that. And remember, this
Yeah.
is just the beginning of your pattern exploration journey.
Right.
There's a whole universe of patterns out there waiting to be discovered.
It's pretty amazing.
And who knows, maybe you'll even uncover a new one yourself.
All right, so as we wrap up this incredible journey into the world of patterns,
Yeah.
what's one final thought-provoking idea we can leave our listener with?
Okay, here's something to chew on.
Okay.
We've talked about how patterns help us make sense of the world.
Right.
But what about the things that don't fit into neat patterns?
Hmm.
What about the outliers?
Okay.
The anomalies, the things that break the rules?
Right.
Are they just random noise? Or could they be clues to even deeper patterns that we haven't discovered yet?
That's such an intriguing thought.
It is, isn't it?
It's like maybe those unexpected things are actually the most important ones,
Maybe.
pushing us to expand our understanding of how the world works.
Exactly.
So don't just look for the patterns you expect.
Oh,
Embrace the unexpected,
right.
the things that challenge your assumptions.
Okay.
They might just be the key to unlocking the next great scientific breakthrough
Wow.
or inspiring a masterpiece.
That's a great note to end on.
It is.
So to our listener, we say this.
What's that?
Embrace the patterns, but don't be afraid of the unexpected.
I like it.
Keep exploring, keep questioning,
Yeah.
and keep that sense of wonder alive.
It's all about the wonder.
The world of patterns is vast and endlessly fascinating.
It is.
And there's always something new to learn.
Absolutely.
Who knows what amazing discoveries await you just around the corner?
You never know.
And hey, if you stumble upon any particularly mind-blowing patterns,
Yes,
be sure to share them with us.
we'd love to hear about them.
We're always eager to expand our pattern repertoire.
Absolutely.
Until next time, happy pattern hunting.
Happy hunting.